We're going to look at estimating the square root of a decimal that's not a perfect square. The example that we have is 5/10 or 0.5. It's not a perfect square, but it is near some perfect squares. We know that our perfect squares have to have an even number of decimal places, so we're going to be comparing this to things with even number of decimal places. So it'll help us out if, first of all, we go ahead and make our number of decimal places even. So I can go ahead and add a 0 at the end of my decimal, because I had no hundredths, and if I put a 0 there, I still have no hundredths, but I have 2 decimal places to work with, so it makes it a little easier. Then we need to think about what perfect squares are close to our 5/10 or our 50 hundredths that we now have. If you think about the 50 that you can see in the 50 hundredths, you can think about perfect squares that are close to 50. So I know that 7 times 7 is 49. That's pretty close to 50, it's just a little bit smaller. So 0.7 times 0.7, which is 0.49, is going to be very, very close to the square root that I'm looking for. Then we also know that the next perfect square after 50 is 64. So the next perfect square after 50 hundredths is going to be 64 hundredths. It's not as close to 50 hundredths as the 49 hundredths was. It's a little farther away. So we already know the square roots of those guys. Those are our known perfect squares. So since the square root of 49 is 7, I know that the square root of 49 hundredths is 7/10. Because since the number that I'm getting the square root of has 2 decimal places, I'm going to need 1 decimal place in my square root. 1 decimal place, when I multiply 0.7 times 0.7, that will be 1 decimal place times another decimal place for 2 decimal places. And likewise, the square root of 0.64 is 8/10 or 0.8. Those two numbers are called benchmarks. They are the numbers that we're going to be comparing our number to in order to get an estimate. So we know that our square root is going to be between 7/10 and 8/10. And we know that it's going to be closer to 7/10 since our number 50, or 50 hundredths, was much closer to 49 hundredths. So we know we're going to be a lot closer to 0.7 than we are to 0.8. So on the surface, it might not seem like there's anything between 0.7 and 0.8. But if we add in, again, our hundredths digit as a 0, then we can think of lots of numbers that are in between 70 hundredths and 80 hundredths, like 71 hundredths, 72 hundredths, 73 hundredths, right on up to 79 hundredths, and so on. So we have to now decide, well, we know our answer is going to be between 70 hundredths and 80 hundredths, but where will it be? So you have to think about exactly how close we are to each of the benchmarks. I'm actually, in this case, very, very close to my lower benchmark. So I'm only going to be a little bit bigger than my lowest benchmark. Right smack in the middle would be 75 hundredths, but I'm not near the middle. I'm really quite near the lowest number. So a good estimate in this case, since I'm so very close to the lower benchmark, would be just 1/100th above it. So instead of 70 hundredths, 71 hundredths. And we're basing that on how close the numbers we're getting the square root of are. So we can finish up by saying that we were asked for the square root of 5/10, and we're going to say the square root of 5/10 is about 71 hundredths.